Now this system is kind of insane. This is one DGX. This is what a DGX looks like now. Remember, just 6 years ago, it was pretty heavy, but I was able to lift it. I delivered the first DGX-1 to OpenAI. That DGX, by the way, was 170 teraflops. If you're not familiar with the numbering system, that's 0.17 petaflops. So this is 720. The first one I delivered to OpenAI was 0.17. You could round it up to 0.2, won't make any difference. And back then it was like, wow, 30 more teraflops. And so this is now 720 petaflops, almost an exaflop for training, and the world's first 1 exaflops machine in one rack. Just so you know, there are only a couple, 2, 3 exaflops machines on the planet as we speak. And so this is an exaflops AI system in one single rack. Well, let's take a look at the back of it. That's the back, the DGX NVLink spine. 130 terabytes per second goes through the back of that chassis. That is more than the aggregate bandwidth of the internet. So we could basically send everything to everybody within a second. So we have 5,000 cables, 5,000 NVLink cables, in total 2 miles. Now this is the amazing thing. If we had to use optics, we would have had to use transceivers and retimers, and those transceivers and retimers alone would have cost 20,000 watts. As a result, we did it completely for free over NVLink switch, and we were able to save the 20 kilowatts for computation. This entire rack is 120 kilowatts, so that 20 kilowatts makes a huge difference. It's liquid cooled. What goes in is 25 degrees C, about room temperature. What comes out is 45 degrees C, about your jacuzzi. So room temperature goes in, jacuzzi comes out, 2 liters per second. We could sell a peripheral. 600,000 parts. Somebody used to say, you guys make GPUs, and we do. When somebody says GPU, I see this. 2 years ago, when I saw a GPU, it was the HGX. It was 70 pounds, 35,000 parts. Our GPUs now are 600,000 parts, 3,000 pounds. That's kind of like the weight of a carbon fiber Ferrari. I don't know if that's a useful metric, but